Hello everyone, my name is Rajan Namichane. Welcome to Programming Tools and Techniques in Data Management class. Today I'm going to discuss a little bit about the SAS programming. SAS is a very powerful statistical analysis tool that is widely used by many academic institutions, pharmaceutical companies, clinical research organizations, and medical schools. Here is the brief overview of my lecture today. Before we start SAS, here is the instruction how to install SAS University Edition. SAS University Edition is a free version of SAS and you can download by following this website here. Let me tell you a brief history about SAS. SAS was first developed by Anthony Barr. He was hired by North Carolina State University to develop some statistical tool that can work in IBM 365 computers. The first program was intended to analyze agricultural data to improve crop yields. This project was funded by NIH. Anthony hired one of his students, James Goodnight, and they both worked together to develop a SAS program. The first SAS program was released in 1971. That program has limited release because it can only work in IBM 365 computers. Later on, after 1 year, SAS full version was released in 1972. In 1976, Anthony, James, and other collaborators started SAS Institute as an independent institute, which is different from North Carolina State University. And since then, SAS has been continuously developing and adding more components in the program. Some of the components of the SAS include JMP, social media analytics, SAS analytics, and AI solutions. SAS, which is also called Statistical Analysis System, is neither menu-driven nor it's one-state command-driven. There are programs such as SPSS and JMP which are menu-driven. You can point and click, then you can get the output. And there are also some programs which are just one step. You can type a command in one step, then you can get the output, but SAS is not like that. SAS is composed of series of instructions which are also called statements to create or analyze or report the data. So you can think SAS is a paragraph of multiple statements. SAS is an order set of statements. This means it has multiple statements, statement 1, statement 2, statement 3, and so on. When it processes, first it starts with statement 1, then it moves to statement 2, then statement 3, and so on. So it cannot jump from statement 1 to statement 3. It has to follow in order. As I said earlier, SAS has developed multiple components over a period of time, such as SAS base, SAS stats, SAS graph, SAS ETS, which is econometrics and time series, and other components too. To check the SAS component in your computer, type this syntax proc set init and run, then select that and run. In the standard SAS program, SAS window looks like this. If you type proc set init and you run it, in order to run this, you select this program, then you go to the command window here, then there is a submit button, so you just submit it. Then when you run, then your log window, it shows multiple components of the SAS program. You see, these are the components of the SAS program, which shows the version of the SAS, when the expiration date is, and it shows what we are using. We are actually using the base SAS software. There are multiple components like SAS stats, SAS graph, SAS ETS, FSP, and so many things. SAS University Edition, your window looks a little bit different than this one. Your window looks like this. It's a similar thing. It has editor as a code, then log file and results. If you type the previous syntax in code window, you'll get the similar outcome. Now let's discuss a little bit about SAS windowing environment. Windowing environment is an environment where we can write and edit the SAS codes. We can submit the codes for the processing. Then you can view and print the output also. There are other methods to submit the SAS program. For example, you can submit the SAS program in multiple batches. That's called batch submission. Or you can also submit the SAS program in the remote server. That's called remote submission. There are other submission methods too, but all of these are beyond our scope. So we only focus on SAS windowing environment. If you are using Windows environment, then SAS window has two primary areas. Here, this vertical area and this horizontal area. This vertical area has two components, results and explorer, and this horizontal area, this has three components, output, log and editor. Results window is a kind of table of content of all outputs. You can see all outputs in one window, and each output has multiple branches. Let me show you one simple example how it looks like. Here I made a SAS program and ran three output. So if you see the result window here, you can see that there are three output. One is print, another one is also print, and the last one is content. If you click this plus sign, then you can expand into multiple branches here. So what we are printing is a data set. You need one L1 SAS data, and if you further click here, then it shows there are two outputs, one in hot HTML format, another one is the list format. And if you click here, then you can see the results like this. You can also click here to see the result. Similarly, there is another print option, and you can do the same thing and see what it is printing. And there is another output of the contents on the same data, and you can see what are the attributes of the content. Means we'll discuss all of them later. What are the engine and what are the variables we used. So if you click here, these are the variables we used. So result is like a table of contents. So it is an easier access to all the output. So you can minimize all of them, or if you want to cancel all these results, if you want to clear all of them, you can go to the results, then right click and then delete. That's what you can do. Then it deletes all the result item. Explorer is an easy access to all SAS files, whether they are permanent or temporary. It contains the libraries, file shortcuts, favorite folders and other folders in the computer. We'll discuss about SAS library later. There are three other major windows in the SAS. One is log. Log shows all the errors, all the warnings, and how the program is running. And it also shows the note. Once you run the program, for example, when I ran this proc contents, it says the procedure contains use this process time, real time, and you don't see any warning or any notation here. Sometimes you may encounter the error like this. When there are the error like this, then program stops running and it doesn't execute. And sometimes you may encounter the warnings. So let me show you how you see the warning. I run this code here. When I run this code, then there is an warning sign. So what does this mean? Even there is warning, SAS is still processed, but your result may not be what you are expecting. SAS identifies this as the minor warning. Sometimes it may be the solution SAS assumed may be correct, and sometimes it's not. All the next window it has is the output window. If you are running SAS 9.3 and later and SAS University Edition, the default output is HTML format. So if you print the data, let me just print the data here, then you see there is one more window appears that is called results viewer. This is the HTML format of the output. So if you are running SAS 9.3 or later or SAS University Edition, then you will see this kind of output, HTML output. You can also list the output. The list output looks like this. You can change the default output options in SAS. In order to change the default output option, you need to go to the tools, go to the options, then preference, go to the results, then click whether you want to list, whether you want to get the result as a listing or you want to get the result as a HTML. Then you click OK. It is not necessary for you to get both of these, but for me, I'll show you both of these. Beside these windows, there are some other commands in the SAS. You can see the SAS command bar here. There is a blank spot here. Similarly, you can see the pull down menus and toolbar here. This one is called SAS command window. Using the command window, you can easily access the data or you can create the new data also. For example, if I do, there are multiple ways to use command window. If I do this, I can easily get this data. So command window can also be used to create the data and it can be used to access the data. And there are multiple use of the command window. If you want to get more information about the command window, please check the SAS document. Also, there are some pull down menus like this. If you click here, you can see how to run the program, and there are many other options here. Similarly, tool and other pull down menus. You can see the pull down menus, and also you can see the shortcut command window here to save, print, or you can print preview, or you can cut, and there are many other, and this is undo. And the most important is this submit command. Every time if you want to execute the program, you need to select the program like this. When you select the program, it is highlighted in blue, then you need to submit the program. There is a text editor window. This text editor window is where we write the code, and this is the enhanced editor, means it has color codes, and this color code indicate whether we are writing good code or not. So this blue means they are good and green means they will not show in the output, and if there is something red, then it means there is something wrong with your code. You may get error or warning message. And this purple, these are case sensitive, means you have to follow exactly as what is inside this quotation. If you are using SAS University window, edition window, then it looks a little bit different, but they are actually the same thing. It has code written as an editor window, log as a log, and results as a results window, and there are other shortcut keys you can use them, and there are other stuff like tasks, snippets, libraries and file shortcuts. You don't need to know much about this for now, but later on I'll tell you a little bit about all of them. For consistency, all my codes and all my lecture notes will be based on standard SAS, not on SAS University Edition. And everything whatever I use in the SAS window, that works for the SAS University Edition also. This first chapter seems very disintegrated because there are many components and you don't see them connecting right now. But when we move to the chapter 2 about data creation, then you'll see how all these components they work together to create a nice SAS program. Now let's go back to the SAS name. SAS name is the name of the SAS variable and SAS data file. SAS data file name could be up to 32 characters or pure in length. And it should not start with any number or any special characters, but it can start with any letter or the underscore. SAS name can contain the combination of all letters, numerals, or underscores, but do not use any special characters like a percentage, ampersand, dollar sign, exclamation, asterisk, at the rate, etc. SAS name, it can contain uppercase or lowercase, it doesn't matter. No matter how you write those names, SAS is not case sensitive. So no matter how you write the name, SAS reads it well. And any mixed case or anything, SAS reads as the same thing. You can name your libraries or SAS data, SAS variable, however you like. There is no restriction in SAS names, SAS library names, or SAS variable names, but it is always a good idea to give some description in the name. This way, you always recall what you are doing and it also reflects what the data is about. Let me discuss about the SAS library. SAS library is a place where you store your SAS data. SAS data, you can think these are the folder of files in your computer. There are two types of SAS library. One is temporary, another is permanent. The temporary library is also called the work library. Your data lasts only for the current SAS session. And once you end that SAS session, then you lose the data. And SAS temporary library is the default storage of the SAS. When you end the SAS session, then your data is gone. But one advantage of SAS temporary library is that it takes less space. And sometimes you just want to run the data and see the outcome, and that time it's very useful. There is another library called the permanent library. It is the location where you store your data permanently. SAS permanent library is a place where you store your SAS data permanently. And this permanent library is user-defined library, or some of the libraries are already defined by the SAS also. Here, if you see the Explorer here, all these libraries except this work library, everything else is the permanent library. This maps, JFK, maps SAS, these all contain permanent SAS map files, and SAS help contains SAS examples. You can use them and you can play with these programming codes. There is also SAS for user, and this SAS user usually contains the formats or informat SAS files. These are also the permanent files. Unit 1 is the user-defined library. User have control to pick the name of this library. It could be Unit 1, it could be my library, or anything you want. So this name of the library, this Unit 1, is not permanent. Every time you can give any, you can reference these data, EX1, L1 SAS data, this data by giving any different library name. These data are permanent but not the name of the SAS library. Now let me discuss how we can create both temporary and permanent libraries, how we can refer the dataset from these libraries. If you want to create a library, here is the syntax. Start with the live name, then this live ref is the name of the library you want to create. This live ref, it can be anything, but it should be 1 to 8 characters long, and it should not start with the number, but it should start with any character or underscore, and it could be combination of any number or character or the underscore, but it cannot start with the number. Then you give the engine. Usually engine is the processing of the SAS, and SAS automatically identifies the engine, so you don't need to worry too much about this engine. In our case, we generally use V9. SAS generally use V9 as the engine, and then this is the path where you want to permanently store your data. Now let me give you one simple example here. Here I'm creating a unit 1 library in this location. Once I run this, then my library will looks like, let me just show you how it looks. Suppose I want to create not unit 1, unit 2, because I already have unit 1 here, so I want to create unit 2 library in this location, and this location is in my desktop inside the folder 501 and programming tools and techniques and data. So if I want to create this data, if you want to create a library in this folder, then all data will be collected in this folder, the last one, this folder data. So if I run this one, this program here, then there is another library created, unit 2. And if you open this, there are 2 data sets I already created. This is because I gave the same path for both libraries, unit 1 and unit 2, and the data are saved in the same data folder. This data folder is in my desktop. So if you want to see here, I go to desktop, then MHC 501, programming tools and techniques, this and the data, and these are the files. So if you give the different path, then you can create a different folder. So if I want to create the data permanent, let me create one new folder here. Okay, test folder. Now I want to create the permanent data on this test folder. So let's find the path. You right click it, then go to the properties. Then you see this is the path you need to give to SAS. Now if I run this SAS code, giving this path here, this is the path. If I run this one, let's say this is unit 3. If you see the log file, it says library of unit 3 was successfully assigned as follows. So if you go back, Explorer shows all the files. So you click the Explorer. Now to go back, to go one step up, click here. Now you see that there is unit 3 in library. This is called active libraries. All these are SAS libraries, and after this unit 1, these are my active libraries up to unit 3. And if I click unit 3, since I didn't create any data, if you see here, if you see the test here, after data I went to the test, then I created the library for test, but there is no data because I didn't put any data in this library. So that's what it will show if you go to the SAS program also. If you click here, In unit 1 and 2 you can see the data because I already had that data, but in unit 3 I didn't create any data, so you don't see anything, that's empty. SAS default is temporary library, so let me create one data here in temporary library. It's already there. Okay. Let me create one temporary data here. Now I'm creating one temporary data here. If you have data in temporary library, they are stored in work library. So work means it's a temporary, and they are temporary because they only last for that session, and if you end the session then you lose this data. So if you want to create the temporary library, you don't need to assign any live name. SAS default is temporary library. Let's discuss how we can refer these files from temporary as well as permanent libraries. There is a rule for 2 and 1 label name. If your data is in permanent library, you need to refer the data by using 2 label names. The format for the 2 label name is libref and dot dataset or libref period dataset. So this libref is the name of the library you have assigned, and dataset is the name of the data. So if you want to refer a data ex1 from unit 1 library, then you need to write unit 1 ex1. So let me show you one example here. So let's go back and see what is in our unit 2 library or unit 1 library. So we have L1 SAS data in unit 1 library. So if I want to refer that data, then the code I need to type is let's see here. I need to type, so I'm printing this data L1 SAS data from unit 1. So this is what I have. Data is unit 1 dot L1 SAS data. This means I'm referring unit 1 library and getting L1 SAS data. Now if you have temporary data, then you don't need to refer by 2 name. You can just keep the data name. Just like this. If you want to refer example 1 in the temporary data set, you can just type example 1. Or since work is a temporary library, you can also give work.example1. So if I print, suppose I have a data A, let's go back here, I have data A. If I want to print this data A, you can just print data A. You can just print data A because it refers the temporary data A. You don't need 2 label name. If you want to give 2 label name, you can write print work.a since this is in the work library. I always prefer not to give 2 label name for temporary libraries or temporary data. SAS is a well-defined programming language that consists of a series of well-constructed statements. All SAS statements, they begins with a keyword such as data, set, run or proc, and they end with a semicolon. So each semicolon represents one SAS statement, and SAS is not case sensitive. So you can write uppercase, lowercase, or mixture of upper or lower case. But remember that even it is not case sensitive, if you write something in quotation, then that is a case sensitive. And SAS statements can be written in one line or multiple lines. So let me show you here. Here in this code, this data is one statement, and I'm writing this input here. If you write here, This input is one statement, but I can break it down into 2 lines, or you can write all these statements in 1 line too. There is another statement cards I'm writing in 1 line, or you can even write all these statements in 1 line. And now each word in the SAS is separated by space. You can write one space or more than one space, it doesn't matter. So this should be separated by at least one space. And if I run this code, this my title here, this is inside the quotation, so this will show as my title in the actual data. So if I run this one, now let me run this code and see what I'll see here. So if I run here, then it shows my title. You see that? So this is exactly same as whatever I wrote here in my title. As I said, SAS statement, it can be uppercase, lowercase, or mixture of anything, but try to write the SAS statement in such a way that it looks nice and attractive. It's an old-fashioned to write all the codes in the uppercase letter, and sometimes it seems too aggressive to me. And that's why I emphasize to write the codes in a way it tells you about the program. I recommend writing the SAS codes in lowercase, emphasizing the keywords by using the uppercase. Also capitalize the words that start and end the blocks, such as data, proc, print, run statements. And I also emphasize to indent or give the white space to make your code more readable. SAS program step is a combination of all SAS statements. Each SAS program starts with either data or proc and ends with run. Each SAS program has data. Each SAS program contains multiple statements, but all of these SAS statements are executed by using run statement. When SAS encounters run statement, then it stops there and execute all previously submitted statements. So each program step, it has 2 steps, data and proc. Each SAS program contains either data step or proc step or both. So if you see this example here, there are 2 program steps. One is data step, another one is this proc print step. So there are 2 steps in this program. Data step is used to create or modify or check the errors of the data, or sometimes it is also used to create new data by merging or subsetting or updating the existing data set. In the data step, we usually have more controls. And in proc or the procedure steps, these are pre-written routines and they have a fixed format you have to follow, and they are used to process the data, present the data in the form of a report, or sometimes you can create the new data with the that contains the result. So this proc procedure usually create the report and list the data and produce descriptive statistics or analysis output, create the summary report, or produce plots or graphs and charts. So SAS program consists of both data step or proc step or any combination of these 2 steps. Let's discuss about the SAS dataset. SAS dataset is any data that is formatted in such a way that SAS can read and run the programs. It consists of 2 parts. One is called descriptor portion that explains about the data. It contains the name of the data, date, time, and other variable attributes of the data. And this descriptor portion can also be obtained by using proc contains statement. So let me show you one example how we can show this descriptor portion. I have a data called Unit 1 L1 SAS data. If I want to see what is the description of this data, what are the contents of the data, I can use this proc contains, and let's see. Once I run this proc contains, so here is my output. So it shows my dataset name, which is Unit 1 L1 SAS data. How many observations are there? There are five variables. Then I used V9 engine for this one. SAS automatically select the engine. I don't need to refer anything. And my operating system is 64, Windows 64. And it also shows me the date when it is created and when this program was last modified. Now, if you go down, there are some engine information that is not relevant to you. And the last one is the variable attribute, means it gives us the type of variable. So I have 5 variables: age, end weight, name, start weight, and team. Age is a numerical variable, end weight is numerical, name is a character, and the length of this variable, length, is a 15 for character given, and others are 8. We'll discuss about length statement later. Now the second portion is data portion. The data portion contains the data values, and it is a rectangular form of table, and where the observations are rows and variables are columns. As data portion, SAS data, they can be either built by writing a program in DataStape or importing data from other formats. We'll discuss how to create SAS data in Unit 2. Now let's discuss about this description portion here. Each row is the observation, each column is the variable, and if there are data here, this kind of data, the character data, are those which cannot be added or subtracted, and it contains the characters. For example, name, you cannot add 2 names. And there are also another type of variable that is called numerical variable. Numerical variable are those where addition, subtraction, or all other arithmetic operations make sense. So you can add, subtract these values. In our case, age, start weight, and end weight are the numeric variables. And there are also missing values. If the values are missing in the character, then they are just a blank here like this. And if they are missing in the numeric, then they are the period. In this data set, we have 5 observations and 5 variables, and this OBS column is a default column by SAS, so it is not the actual variable in our case. It just shows how many observations are there. You can get rid of this OBS or this column by adding OBS option in the print statement. So let me show you how you can see them. So if I print the previous data, so my output looks like this. There are 5 observations, 5 columns. Now I want to get rid of this OBS, so now I have a command here, print data, and then I provide no OBS, means no observation option here. And if I run this one, because I don't want this title, so I can just write title. So if I run this program here, then I can find all these. There are 5 observations, 5 variables, but there is no OBS column. So in previous I had OBS column and title, but now I get rid of the title also. SAS comments are very useful statements in SAS programming. They allow you to document your code. When you come back to your code after a few days, you may forget what you were doing. So if you write good comments, then you'll be able to easily track what is going on in your code. So I always prefer you to write comment in each programming. There are 2 ways to comment in SAS program. First method is start with a star, let's say which is comment, then end with a semicolon. Then your comment shows up in a green color. Green means it will not be printed out. Now another way to write the comment is slash and star, then this is just the forward slash and star, then you can write comment and then you end with star and slash. So you can write comments, multiple lines of comments It doesn't matter how long you want to write. Then you can close with the star and slash. There is also a shortcut way to write this later version of comment slash and star. So you can write any comment, then press Control and slash, then it writes the comment in slash and star format. My recommendation is to use this slash and star comment rather than just the star. Always comment your code because you'll forget what you are doing and why you did it. And it is also very helpful if there are multiple collaborators working in the same project. It is useful for all of them to understand the code. Let's discuss about SAS variable attributes. There are two major types of variables in SAS. As I already said, numeric and character. Numeric variables, they can be added, subtracted, or could have any decimal place, plus or minus signs. And the default length of SAS variable is numeric variable is 8 bytes. So 8 bytes is it's a floating point values and the maximum up to 15 decimal place. And this could include any numeric from 0 to 9, plus or minus, or even the scientific notation E. If you want, usually for numeric you don't need to change the length because it can hold up to 15 significant values. But if you need to change the length of those variables, then you can provide the length statement. Sometimes providing smaller length save the space. SAS character values are letters or some special characters, a combination of numbers and letters and so on, and these values, they actually do not make any sense when you add or subtract. For example, if you have months, then adding January plus February doesn't make sense. And colors, red, blue, white, when you add in data, then it doesn't make sense. Those are called the characters, and default length of each character is 8, means you can only write the character length of 8. So I'll show you in next example. And but you can extend the length of character by up to 32,767 characters by providing the length statement. But when you provide longer length, then SAS take a lot of space, and it sometimes if your value is smaller than the length, then SAS adds the spaces to those values. And sometimes some values we represent as a number, but they are actually the character values. For example, gender, sometimes when you write 1 and 0, it means 1 for male or 0 for female. Then you can write 1 0 for gender, but 1 0 doesn't mean it's a numeric, it's a character value. Similarly, for months, if you write January, February up to December, then SAS usually sort them by alphabetical order. So instead of January, maybe April will come first. But if you want to create the data with the ordered month, then you can write the month as 1 to up to 12. By that way, SAS always order the data by correct month. In SAS, missing values are represented by either blank or period. If the missing value is in the character, then it is represented by blank, while it is period in the numeric variable. There is another special variable called date, time, and date time. Date stores the number of days starting from January 1st, 1960 to the given date, and time represents the value stored as a whole as the number of seconds since the midnight. And date time is the combination of both data and time, so it stores the number of seconds from midnight on Jan 1st, 1960 to the given data and time. Let me show you one example that shows the variable attributes. Suppose I have this data and I want to print all of these names like Michelangelo, Anuja, and Hampshire. And if I print this data by using this print command, this looks like this. So it's not printing all the character values. All these amounts are printed here, but not all the character values. So instead of Michelangelo, it just printed Michael A, means it only consider 8 characters. But amount we are fine because we can go up to 15 digits, digital values, even more. That depends on the floating point. And if you see the content of the data by using proc content command, the content shows that the amount is a numerical variable with length 8, date is a numerical with length 8, and person is a character with length 8. But this length 8 cannot write the name Michelangelo. So how do you increase the size of this length of this person variable? So to increase the size, always provide length command before you input anything. So we want to increase the length of person up to, since it's a character variable, we give the $sign. We want to give this up to, there are 13 characters in this Michelangelo. This is the largest label of this, largest data value of the person variable. So there are 13, so we give this 13, length of 13. And we run the code, and let's print the data again. Now this time, look here, we can print this Michelangelo everything. So up to 13 characters we can print. But when you provide the length, you see that in previous case our data looked like this. Amount, person, and date, how we input here, amount, person, and date. When you had amount, person, and date, this person was not complete. I mean, all values are not shown here. But now when we provide the length statement, then we can see all value of this variable person, but this person came as a first column. So we can interchange the column later by using print statement. I'll show you later. SAS always store date time and date time in the as a numeric variable so that it can easily do algebraic manipulation between these variables. It can determine the interval between the dates, add dates together, add a set of number hours, and it can do many arithmetic operations in the data and time. SAS data and time can be referred using DDMMYY format or DDMMMYYYY format, with D is the total number of characters needed to represent that format. We'll discuss more about date time in later chapters. Format and informats are two very useful tools in SAS. Format is the way how data are displayed. If you record the data including the character like a dollar or comma sign, SAS recognize that data is a character data. So what we do is we record the number as a numeric data in SAS, then we display them using the format in our required format. For example, if we record the data as 2356 as actual data, and if we implement some format like $9.2, then it represents this data in this format, $2356 with 2 decimal place and comma also. So how do you identify this? how do you write this 9.2 or 10.2 like these values? So this 9 indicates the total number of characters or values you need, and 2 is, after decimal, it's a number of decimal place. So the format is format WD is the syntax for format. Or if you don't have decimal, you can only write format W. W is the width of the format. So if you see here, how many characters are there? 1, 2, then period makes 3, 6, 4, 5, 6. This is 7, 8, and 9. So we can have the total width of 9, and that includes 2 decimal places. That's how we define the format. And for date and month also, there is another format called month name E3. Month name 3 means it can write the month name in 3 width. So this is, if date is 10, means it is October. And if you have this date 9 format, means it can represent in this format. So how do you get this? This is the total number of days. Date is date format, total number of days from January 1st, 1960 until 17 March 2000. That's why the date is represented in this way. But date time format will be discussed later. As format displays the data, in formats they read the data. When you create the data from text file or rich text file, then you can give in formats to record the data. Suppose you have data written as this in dollar format, like $12,345 and up to 2 decimal place, then you can use the comma in format, comma 10 in format to record this data, and it will be recorded as 12365 only. And when you have comma 10 in format, and if you want to display this data again, use the format with the $10 decimal 2. So there will be total 10, and that includes the 2 decimal place also. So let me show you one example how we can incorporate this format and in format and even date time in a simple data set. Now let's go back to the previous data where we already fixed the length of this person variable. Now if we run this code here, if we run this code, this data will be printed like this here. Let's go back to our previous data where we already fixed the length of the person variable. We want this data to be displayed in this format. We want this data to be displayed like this, where we have date is written as MMDD and all complete name of the person, and this amount will be in the dollar format. So how do we write this? Because your actual data, the original data in the SAS, it looks like totally different than this. The actual data looks like, if I run this program here, the actual data without format looks like this. If you see here, there is no dollar sign, no comma or nothing, and even date is reported as a number of days from January 1960. So you don't know which date it is. So how do you change this? How do you change this display? So you use the format option in the print. So when you use the format option, let's see the amount. Here we want to write this amount in the dollar format. So how many decimal place we need? We need 2 decimal place. Now including decimal and other commas, what is the width of the format? How many characters could be there in this format? Let's count them. 1, 2, this period makes 3, then 4, 5, 6, there will be one comma here, 7, 8, 9, 10, there will be another comma here, 11, this is 12, 13, and there will be dollar sign here, 14. So the total width should be 14. with a 2 decimal place. Now let's go to date. Date, we want to represent the date is dd, dd, then slash yyyy. So in total there are 10 characters. So this format will be ddyy 10. So if we write the format of amount is $14.2, date ddyy 10, then let's forget about this part for now. If you do this, then and if we run this data, then we can see exactly what we were looking for. So this is date in ddyy format, and this is the amount. Now if you see carefully, in our previous data it looks like observation with person, amount, date, but our actual data was reported as amount first, then person and date. If you print the actual data, it should look like the actual data looks like, then the actual data was like amount, person and date. But when we change this length here, we define length first. So SAS treat this person as the first variable. In data step, when you treated this person first, then SAS decided this as a first variable. That's how your output looks like: person, amount and date. Now how can you change this order of these and remove this observation, because this is not the column we want. So to remove this observation, we write no observation. And now to keep the order of the original data, you can type the order in variable statement or var statement. So order was amount, person and date. So if you keep these, now if you run this program here, if you print this one now, if you print this with amount, person and date option, now you see that this is what we are looking for: amount, person and date in the correct format, dollar format, correct date format. In the past we had person, amount and date. We find person, amount and date. That's not what we were looking for. We were looking for amount, person and date in this order. So you can do these things in the proc print command to display the data. Now let me explain a little bit about the hierarchy of the significance of these special characters or values in formats and informats. So this hierarchy is coming from top to down, means if there is not enough width, then the top one will be removed first, then the next one, and so on. So it is removing from top to bottom. So for example, let's say we have original value 15,585, and if we use $10 format, then you have all these here, and it adds more space in front of it. You see that there is space because it only needs 1, 2, 3, 4, 5, 6, 7 characters, so it adds 3 more space here. If you go up to 8, it still adds 1 more space here. If you have 7, then it's tight. The length is 7. Now suppose instead of $7 you have $6, then what happens is there are total 7 of these. Now it has to remove something to make width 6. So what should it remove? We have dollar and comma, so you see here in the hierarchy, this comma should be removed first. So it removes this comma here. Now, if you have $5, means if you have only 5, your width is only for 5 characters, 5 values, then it should remove another one in hierarchy, which is $sign. So it removes that. Once it removes $sign, let's say we have 4. 4 means you round up to that. So when you round up, then you have scientific notation E here, means 1/5 is 6, means it round up to this 3 decimal place, 1/5, and then 15.6 times 10 to the power 4. That's what it is. And similar concept for the informat also. In general, informats are implemented in the data step, and formats can be implemented in both data and proc steps. Why informats in the data step? Because data step is to create the data, and informat is for reading the data, and format is for displaying the data. Now let's discuss about some other SAS options. These are the global options. You can use them without any run statements. So these options, they work for the entire SAS session unless you overcome that option by some other options. If you want to see the available SAS options, you type options, run. You can type proc options and run. If you run this program here, you don't see anything in the output for this. Let me clear this one and run one more time. If you run this, there is nothing in the output, but in the log you will see the several options here. These options tells you how to control your font size in this display, how to control the font size in the output display, how to allocate the memory size to memory for the SAS program, and so on. So if you see this log, you can see that the memory size, the maximum memory size for the SAS is this 2 GB memory size, and similarly you can see the memory size allocated for the virtual memory for processing is also 2 GB. So you can see many other options here in proc options. You can also get the group options, means you can get the subgroup of these options. For example, if you just want to see the memory options, then type group as memory, then run. You can only see the memory options here. This is the memory option, sum size, max memory, query, and so on. SAS options can be local or global. Local means that only lasts within that data step process, and global means it lasts for the entire SAS session. And you can change the options how it shows the display output. You can change the line size, how many characters will be there in one line. You can change many other options. Please do more research on the options, and we'll come back later by using some local option also. Let me review whatever we have already done about running the SAS program in the window environment. So in order to run the SAS program, you need to select what you want to run. For example, this is one entire program step. Program step starts with some data or proc statement and ends with the run. Each SAS, when it encounter run statement, it always stops there and execute all previous statements. So here at this run statement, now SAS executes when you submit it to the execution. So you submit these, then it runs. So in order to submit, you just select the code and submit. Or you can select the code, go to run and submit here. Same thing. I hope this introduction is very helpful to you. In our next section, we'll review about the data step and we'll see how SAS stores the data in its temporary memory and how SAS data are created from the raw data. How can we import different formats of data using the import wizard? How can we export the data using the export wizard? Also, we'll discuss about the contents of the SAS data, how to view them, and there are multiple output options. We'll discuss some of them. I hope you enjoyed the lecture today. I'll see you next week.